For Ms. Rara, the time is yours.
Okay, thank you very much, Ms. Sinta. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. Respectable Chairman of Mathematics Department, Dr. Anda Media Rosa, MSI, the Honorable all lecturers of Mathematics Department, and Honorable all participants of this virtual conference. Welcome back to the 6th International Conference on Mathematics and Mathematics Education 2022 third annual session. Ladies and gentlemen, I am Rara Sadiwinanda, and I'll be moderating this third panel discussion. I am delighted to see you all here and would like to welcome you all to this conference. Today's panel discussions concerns about COVID-19 modeling in Indonesia, one wrong question, and what we should have learned. Okay, Professor Dr. Hadi Susanto, MSc, will be our speaker today. And then I would like to extend my greeting to him. Assalamualaikum, Prof. Hadi.
Waalaikumsalam warahmatullahi wabarakatuh.
Welcome back to Universitas Negeri Padang, Prof.
Thank you.
Prof. Hadi, the next hour will be devoted to a presentation, during which you will speak for around 30 minutes. Following the presentation, we will have a discussion lasting as approximately 30 minutes. In addition, our audience consists of lecturers and students from Indonesian and international universities. Okay, Prof. Hadi, I will read your profile first. Okay, Professor Hadi Susanto is a member of the Department of Mathematics at Khalifa University in Abu Dhabi, United Arab Emirates. However, he is an Indonesian who works there. In 2001, he obtained a bachelor's degree from Institut Teknologi Bandung. In 2003 and 2006, he received his master's and doctorate from the University of Twente, Netherlands. In 2013, the UK's Higher Education Academy. Prof. Hadi has a background as a lecturer and professor at different universities. Some of them held the position of visiting assistant professor at the University of Massachusetts from 2006 to 2008, lecturer in applied mathematics at the University of Nottingham from 2008 to 2013, and senior lecturer in applied mathematics at the University of Essex from 2013 to 2019. Additionally, become an adjunct professor at Institut Teknologi Bandung from 2018 to the present, a professor of applied mathematics at the University of Essex from 2019 to 2022, and a professor at Khalifa University from 2020 to the present. In addition, he has received the honorary membership of the Physical Society of Uzbekistan, the World Class Professor Awards, and the Ganesha Prize. Ladies and gentlemen, before the presentations begin, I will explain how it will be structured. First, the talks last approximately 30 minutes. Second is the question and answer period, approximately 30 minutes. Each audience member may pose a question. If you have a question, please use the Zoom meeting raise hand feature and unmute your microphone and camera. Alternately, you may put your question into the chat box in the Zoom program, and I will read it out loud while the final is the conclusion. Okay, permit me to introduce the presenter, Prof. Dr. Hadi Susanto, MSc, who will be delivering his presentation. So Professor Hadi, are you going to present your PowerPoint presentation by yourself?
Yes.
Okay. Okay, time is yours, Prof. Hadi.
So, firstly, Assalamualaikum warahmatullahi wabarakatuh. I would like to thank the organizer for the opportunity to be at Universitas Negeri Padang again. I think it is the second time, first time virtually. Was visiting UNP the last time, I think, when was it? 2017, I think. Yeah, it was a very nice visit, a memorable one, where yeah, I met many of the staff members in the mathematics department, Bu Media, and then Burara, Pak Defri, and certainly Pak Prof. Fauzan. So I hope I will be able to visit UNP again soon, physically, if time and condition permit. So secondly, I would like to thank the audience for joining me this afternoon. I hope you will learn something. We will learn together. And as you see from my slides here, I'll be talking about COVID modeling in Indonesia. There will be no mathematics, okay? So it will be more on to an overview of what we have learned so far, almost 3 years now, and what we have learned and what we should have learned, and what can we do as mathematicians in the future, because what we experience, what we have been experiencing, it's not going to be the last one for sure, and it was definitely not the first one as well that that occurred. Okay, and what I'm going to present to you is actually a result of my study and learning together with my colleagues and teachers at SimCovid. So SimCovid is simulation COVID in Indonesia. There's a consortium we formed together with a couple of colleagues from different universities abroad and in Indonesia, and all members are Indonesians, but we might work abroad as well. So please do not be scared that I might be talking heavily with mathematics in this talk. So it's going to be more like a discussion and reflection of what we have gone through. As I mentioned before, actually, infectious diseases that occur in the world, what we experience now, definitely is not the first one that happened. And these are some examples of infectious diseases that ever occurred in the world. And there are 3 kinds of diseases here, denoted by different colors. The red one is newly emerging. This made in this slide was prepared in 2015, so it was new at that year. And then the blue one is re-emerging or resurging, which means that it was gone for a while, but then appear again. And then what is important is the black one here, which is deliberately emerging. What does it mean by deliberately emerging? It means that it was purposely. So someone intentionally created the disease to emerge again. Okay. So, for example, in Indonesia, and not just so this one Nipah virus was in Malaysia, actually, very close to Indonesia. And then enterovirus 71 was re-emerging, was gone and then appear again. So these are all, this is that ever occurred. And now the black one in this case is only one, which is anthrax bioterrorism. I don't know about our audience in our meeting today, but for those who were born after what was it, the terrorist attacks in the US. I don't know if there is any in the audience born after that. So this one was a virus that was taken from a lab and then spread through mail post by someone. It was done to create fear in the US. Even though it was not a big, there were not many casualties. I think only less than 10 people died. But still, this is an example how diseases can be used as a weapon. Okay, and it is not a matter of fiction or just imagination, but this ever happened before, and it's not impossible that it may happen in the future. Now, from these pictures, if we look at the timeline and also the number of deaths that appear, so these are all big pictures of diseases that claim many lives in the past. Okay, for example, HIV, it was found first time early 80s. Until now, it's already claimed 25 to 35 million's life. Okay, million. So 25 sampai 35 juta. And then, of course, the recent one that we are now experiencing is COVID-19, of course. This picture was prepared in 2020. So in the very beginning of the pandemic, a pandemic started in December 2019. So this is basically about roughly 4 months after the first incident. It was 171,000 deaths. Now, if you look at the latest data, it's already 6 to 7 million's lives, taken by COVID-19. So the size would approximately be half of this, of the third plague in 1855. So half of this one, so the size. And even then, the 6 to 7 millions reported by WHO, that cannot be the real number, the exact number. The exact number is much bigger than that. We will discuss later, and including research papers that explain why the numbers bigger than what's reported. Now, as I mentioned earlier, of course, we do not want it to happen, but as our world grows, so the infectious disease threats. So basically, as the population of human being increases, then the threat for infectious disease is also increasing. Why is that? Actually, because human being invades nature. Okay, we diminish forests, we cut trees, we do biotechnology, and so on and so forth. Why? Because we need food. As the number of population increases, the more food's needed. So we have to do something. And what we do here doesn't come for free. It comes with a price. And one of the prices that we have to pay is diseases. Okay? Including like COVID-19, we hear that it came from animals. So something like that. So that's why if the number of population increases, then we have to be ready as well that infectious disease also will increase as well. And this is quite frightening, that the prediction is by 2050, human population will be about 9 to 10 billion. So you can imagine how the threat by that time. And that's why we have to be sort of prepared in this case. And then as a mathematician, and also the theme of the conference here, now the question is, where is the position of mathematics? Okay. Of course, we have seen the position of medicines, pharmacies, doctors, medical doctors, and so on and so forth. But because I'm a mathematician, so what is the position of mathematics? And historically, I would like to use this case as my starting point. This one here is actually a picture of smallpox. Okay, that in the early, I think late 70s, so 79, I think. Yeah. So this one is a smallpox, and what we had, I guess, for most of us, or if not all of us, we must have had chickenpox before. Okay, so what is the difference between smallpox and chickenpox? So these are some scheme comparison between the two diseases. Smallpox was dangerous and can claim life, as we see later. However, because of vaccination and medical treatment and medical technology that we have, so smallpox has been declared as eradicated, so gone. It's already no smallpox anymore. It was in the late 70s. Now, regarding, just 1 second, please. So I would like to quote a statement from Danielle Bernoulli. So some of us might recognize the name. He was from the family of Bernoulli, a name that we saw in many places in textbooks. Okay, so Danielle Bernoulli was one of the scientists at that time who helped convince the people at that time that vaccination is important. So what did they do? What kind of vaccination they did for smallpox? So what happened was that it was originated in India, if I'm mistaken. So what happened is that at the time, because of the smallpox incidents at that time, so what happened was that those who got smallpox, they got blisters, like what we saw before, right? They got blisters like this. So what they did was that at that time, the need for people with blisters like this was increasing. So those who were sick, they got paid for the blood to be taken, yeah, for the pus, for nanahnya untuk diambil, mereka dibayar. They were paid for the sickness that they got. And then what happened was that doctors at the time, they dried the blood or the pus, and then mixed with something. I'm not sure what it was, and then they blew. So this is a doctor that blew this dried material into the nose of healthy people. Okay, so the idea is to introduce the body with smallpox virus. And then because of this treatment, there was an explosion of sick people. So the number of people got infected by smallpox suddenly, of course, exploded. Yeah. So, and because of that, people at that time were worried, and also politicians, the government worried whether it is a good idea to do this kind of vaccination or just let it happen naturally. And so just to cut the story short, because I don't have much time, Burara, how more minutes? I did not recall the time I started.
You still have about 15 minutes.
Okay, 15 minutes.
Yes.
Okay, so for those interested in this, I would encourage you to read this paper here, Danielle Bernoulli's epidemiological model revisited. So Hans Esterbeek here made a very nice review of what Danielle Bernoulli's wrote and analyzed and convinced the people. And even because of his efforts, I would like to quote here because his modeling. So he convinced the government that vaccination is better to do. Do not stop vaccination, even though the number of infected people increased very quickly. And if you read this, I simply wish that in a matter which so closely concerns the well-being of the human race, no decision shall be made without all the knowledge which a little analysis calculation can provide. Dalam bahasa Indonesia, berarti Danielle Bernoulli berharap bahwa setiap kebijakan yang menyangkut hajat hidup orang banyak tidak boleh diambil tanpa matematika. Okay, so a little analysis here means mathematical analysis. So it was a nice statement that I think we should take. So what is a mathematical? So what is the role of mathematics? It will provide. One of them is provide mathematical modeling, and with mathematical model, it's actually a two ways interaction. One is forecasting. Yeah. One is forecasting and evaluation. So calculate risk and benefit, and this forecasting and evaluation can be used to influence national policies, and then after a policy is implemented, then the mathematical modeling can be used to evaluate again. And in the beginning of COVID-19, we saw several examples of how mathematicians and scientists were consulted. Okay? And I do not want to use used, but consulted. For example, here the Dutch government used Jacco Wallinger. If you check on Google, Jacco Wallinger is one of the most prominent epidemiologists nowadays. So the Dutch government used Jacco Wallinger to get feedback and also to model what the government must do. And then there is a nice case, a nice example here in the UK. So if you remember, if you followed the news from the UK in the very beginning, so it was in January or February, the UK government decided not to lock down the country. Why did they do that? Because of a mathematical report from an Imperial College group here that claimed, or based on their analysis, that if the government did lockdown, once the lockdown is lifted, then the second wave will be much larger. And because of that, so the government decided not to lock down. However, what is interesting, the same group made a correction to their model. They say that, no. If we did not lock down, then basically the medical facilities will suffer. We would not be able to cope with the number of sick people. And because of that, instead of proposing not to lock down, so the same group proposed lockdown now. And see, what happened is that they made this analysis, released the analysis on the 16th of March, and then a week later, the UK government decided to lock down the country. So the UK government really followed analysis from mathematicians, and also in Germany. And for Germany, it's a different case. Why? Because the prime minister herself is actually a scientist, you know, or former prime minister of Germany at that time is actually a scientist. She has a PhD in chemistry. Actually, there is this is a movie of how when she gave press conference, how she could explain mathematical terminologies, mathematical models in a nice way. But because of the time limit, I'm not going to play the movie. So let's go to the next one. Now, what about in Indonesia? This is what interesting. So in the previous cases, the government took seriously feedback from scientists. But in Indonesia, Pak Ahmad Yuryanto, almarhum, he said that what scientists say about pandemic are not important if their information only creates panic. So in the beginning, there was a different attitudes of how our government reacted to what scientists say. And even we read this before as well. We heard an interesting statement from our former Minister of Health, where basically our government did not believe of what the scientists say. Scientists say at the beginning that at the time there was already COVID-19 in Indonesia. Now, you may wonder, I'm sure we all have heard already what the minister said before at the time, but did we know which scientists or the US study here that they were talking about? So actually, the US study that the minister referred to here is actually this paper. It was put in February 2020, so in the beginning of the pandemic, using simple analysis. Basically, it's just a simple statistical analysis. You just use a regression. They concluded, so at that time, there were countries already reported the occurrence of COVID-19 and infections. And based on reports that they received, they used a simple statistical analysis, just a regression, and then using interval of confidence and so on and so forth. So good countries would be in along the line here. Above the line, it means the country did quite well with preparation for COVID-19. Now, what we see is that, so the conclusion is that every 14 passengers, so setiap 14 penumpang international, tourist international, actually correspond to one additional imported case. Jadi setiap 14 penumpang internasional dari Cina yang datang ke sebuah negara, maka seharusnya ada satu kasus yang ditemukan. Now, for Indonesia, the number of passengers arriving per day is at this point, but by that time, February 2020, there was no reported of infected cases. So that's why it's not just below the straight solid line here. This one is even the lower confidence, which means that Indonesia was not doing very well at all in preparing for the pandemic. And then, so we saw that in the beginning we denied, and then after that, cases exploded, and the increment was exponential, which was agreed with a simple mathematical prediction. And then came question with forecasting, question about when the pandemic will end. So these are some snapshots I took from our newspapers on different predictions, different models made by different groups in Indonesia. And what we saw before was that many prediction in the beginning was like it's gonna finish before the pandemic's first year. However, as we see from the latest report, basically it is almost like a periodic occurrence, which was far away from the prediction, okay, from the forecasting. And then we claim that well, it was wrong model, wrong calculation, and so forth, and so on and so forth. Actually, it was not just us who made the same mistake. So it was first message I want to learn. First message I want us to learn is that mathematics is important, the position is important, and government should listen carefully to scientists. And the second message is that we learn that the question of what or when would be the peak of the pandemic was the wrong question. Okay. And the mistake was not done just by us, but also many other scientists in the world also made the same mistake. For example, a group from, if I'm not mistaken, I think it was from either NUS or NTU, Singapore, made the same prediction. In April, they say that it would finish in a month's time. So April, and after a month it will be May, but then a week later, move from May to June, and then in May, prediction move again to September. So also wrong prediction. It's not wrong prediction, but the way we read the data and did our modeling was not correct. So the way we interpreted the model is not correct. Because of the time limit, I'm not going to go into the detail, but these are, so we can explain what happens with the other cases, how the prediction looked very good, but not in the case of Indonesia and other countries. There are some explanations already now, but on top of that, so maybe this is the only mathematical model or mathematical equation I have on my slides. So most of the model that we use is actually using the so-called compartmental model, SIR, where basically people are grouped into three categories: healthy, infected, and recovered. Okay, and then there are many other modifications, which basically just an extension of the well-known SIR model here. Okay, I think my last slides. So what is a problem? So this is what I wrote in our short review paper. So basically, for a long-term prediction, the SIR model only works for herds, okay, not people. Why? Because people adjust it to the environment. You see that herds like cattle, like cows, sheep, they cannot think. They don't think. They don't see their environments. But people reacted to environments. If they see that there are a lot of sick people around them, they would retreat. So changes in behavior. So that's why we cannot just use SIR to make a long-term prediction. But instead, we have to use the SIR model to predict if people do not change their behavior, if government does not change their policy, what happens. And then as soon as there is a change of policy, then we have to revise our model again. So that's the two ways picture that we saw in the beginning. Okay, so that's the the message that I want to inform the audience of my study that we reported in this paper. Okay, so as a closing statement, second closing statement, I would like to invite the audience, if any of you here would like actually interested to do PhD. I think I already mentioned this to a number of times, but at mathematics department at UNP, the Budara, are free. So we have continuously open studentship for PhD at Khalifa University, and the stipends that we offer is quite generous. It's much more generous than the not just the Indonesian scholarship LPDP, but also from Western scholarship standards. So it's very generous. So if you looking for studentship to do a PhD, please do contact me, and we might see what possibilities and what opportunities are available at the university. So, as a conclusion, this is what we saw before, that our mathematical model actually can be used and should be used to understand real situation, and then to give feedback to the government or policymaker. But it is not just one way, but it is a two ways interaction between real situation and policy making and mathematics. So thank you so much for the opportunity. I finish my presentation.
Okay, Prof. Hadi, thank you so much for your educational and engaging talk. Okay, ladies and gentlemen, now please proceed to the question and answer segment. I would like participants to submit 3 questions. Please use the Zoom conference raise hand feature, then unmute your microphone and camera. Baik, para peserta bisa bertanya dengan menggunakan feature raise hand pada Zoom meeting-nya masing-masing. Silakan 3 pertanyaan pertama dibuka. Is there any question? Okay, maybe for the first time, I will ask the question, Mr. Hadi. What's your suggestion or advice for students who wants to have a research in mathematical modeling?
That's a good question. So for students who are interested in mathematical modeling, firstly, of course, study well, and then contact your lecturers. Because of course you can start doing stuff by yourself, but it will be easier and faster if you collaborate with your teacher, with your lecturer, with your professor. And in that case, then the speed to learn is going to be multiple times faster than studying by yourselves. So that's my suggestion, Budara.
Thank you, Prof. Hadi. Maybe
also,
the next.
Yeah. So now, for example, I was using smallpox as an example. Now we heard increasing cases of monkeypox, for example. That will be interesting as well to be studied. What kind of model that we can create to explain why monkeypox is now moving from Africa to outside. So there are many interesting questions, actually.
Okay, thank you, Prof. Hadi. Maybe there's another question from the participants.
Question. I hope because it's
okay. In the chat box, we have a question from Mr. Suhadi W. Saputro. Basically, a mathematical model for spreading any diseases use similar methods. Is there any specific characterization of model for every disease?
That's a very good question. What I understood is that every disease has its own characteristics, and such characteristics, of course, should be manifested in our model if you would like to capture the situation well. Now, of course, in capturing the situation, there are two different mainstreams. The first one is those who would like to explain qualitatively. Even qualitative explanation is already enough for them, as long as they could understand what's happening and why it is happens, and they're already happy with that. And then the second mainstream, the second group, is those who would like to be able to model and explain a disease on a quantitative level. And in this case, usually the second mainstream here are the ones who be able to capture the specific characterization of a disease more precisely. Okay, because they need to be able to capture things quantitatively. Okay, so so the characterization depends. So the characterization depends on the disease, and it may not be our or beyond our capabilities, our expertise to be able to tell what is a characteristic, and we would need colleagues from the health department to be able to tell us what the characteristics are for a disease. Yeah, so the answer is yes, definitely. Every single disease will have their own characteristics, and to be able to capture things quantitatively, then the characteristics must be implemented in the model. And usually this characteristic can determine, or usually will determine, how many compartments, for example, how many groups, or how many variables we have to include in our model. That's my my take.
Okay, thanks, Prof. Hadi. Maybe the last question from I saw someone raise their hand. Miss Sinta.
All right, what an insightful presentation, Mr. Hadi. I'd like to ask a question about, can COVID-19 re-emerging someday, or does the mathematical model forecast about it? Thank you.
Yes, thank you for the interesting question. I think, to be honest, I would not know the answer. Okay, because it is more the answer for epidemiologists and health scientists. But from what I learned, from what I read, from references I have so far, there is a possibility that this COVID-19 might appear again, even whether it is still an epidemic, or it has to be declared as an endemic. It's still in discussion. And if it is declared as an endemic, then of course there may be some possibilities that it will appear again in the future. So it is very interesting, and there are opportunities for us mathematicians to participate. And if you look in the beginning of the pandemic, at that time, that actually because it was new, the disease was new, almost nobody knew about the disease. It was a good time actually for us, for mathematicians in Indonesia, to be in the same starting position as other mathematicians in the other countries, yeah, obviously those in developed countries. Of course, in time, the way they move forward with their work, of course, is it will depend on facilities, experiences in the past. But there was a moment, what I was saying, there was a moment where we were standing in the same line. We were standing in the same starting position. It was interesting, and there is the possibility is not zero that it will happen again in the future. Of course, hopefully it's not going to happen. Of course, we will always wish for the best, but the possibility is there.
Okay. Prof. Hadi, maybe the last question. I still have a question for you. I've ever heard that in our words, there's a natural selection that every 100 years there is a pandemic to attack the world. So what do you think about it? Is there an epidemic will still exist in our arts until now and for our future? Because it is it just a natural. It is kind of a natural, not because of behavior of human, I think. Do you agree that the pandemic is still exists in maybe every 100 years with any different name? Maybe now we have a coronavirus, COVID-19. Maybe next year we have another pandemic. What do you think about it?
Even actually saying that every 100 years is too optimistic. It's not, even statistically, is even much less than 100 years. So diseases, infectious diseases appear less than 100 years. So yeah, so saying that it happens every 100 years is actually on the positive side. We look things very positively, while realistically it's much sooner than that. So yeah, so I believe that we have to be prepared, we have to be ready, and also we have to control in the way we perhaps not us, but human being, and how we interact with our environment, with nature. Yeah, if I may, there is an interesting remark. This is rather a remark than a question from Bu Triweni here in the chat box. May I answer that? May I comment on that?
Okay.
So Bu Triweni say, what is challenging in the future regarding the mathematical modeling, especially when data is too big or even it is hard to find real data? Yes, I guess I believe Bu Triweni already knew the answer to this question. So I take this as a remark. It's indeed that so what we have experienced so far is actually a very interesting learning process for us, that mathematics can learn a lot from our shortcomings in data, for example. So due to COVID-19, I think not just mathematical modeling like from SIR or ODE's community learn a lot about the way they or we viewed our model, but also many other areas in mathematics, including analysis of what's called I can't remember the exact word. Quantification. error quantification. I think that's what it was called, because it will be related to the difficulties in finding data that can be believed to be correct. Okay, and also when the data are too big, how we take the right feature. There's also a very current and important questions that still has a lot of unexplored areas. So indeed, there are many ways that we can go with mathematics, and we as mathematicians, I think we are in a better position because we don't need too much expenses, too many facilities, supports to learn those things. And for example, about this error quantification, I think this is a very interesting paper. If I may present one slide, Burara, just one more slide, and then I will finish my talk. For example, this paper, it was last year. It is in Nature Communication, and for those who are not familiar with Nature Publishing Company, so the Nature itself, the Nature journal, is at the very top level of scientific journals, and then below Nature there are many other new journals specialized, and including Nature Communication. So this Nature Communication is very prestigious journal, and this paper is very interesting. Why? Because it was done by this group of people or scientists in Italy. They used statistical analysis to discuss that the number of COVID-19 deaths in Italy that was reported officially was only 36,000. Okay, the number of deaths reported by the government was 36,000, and they use statistical analysis to claim that actually the number is almost twice. The actual number is almost twice. Okay. So we can imagine what happens with Indonesia. The number of casualties already in millions. And then if we just use a brute force comparison almost twice, then can you imagine how many people died already because of COVID-19 in Indonesia? Okay. So this one here is an example of a new method, or at least a new application of statistical analysis that was not there before. So yeah, to return to Triwani's remark, there are many things that we still can contribute to the community, to mathematics, especially related to infectious diseases that might appear in the future.
Okay, we still have 2 more questions in chat box, Prof. Hadi.
Do I still have time?
But the time is almost over. The first one from
Zulfi.
Zulfi.
Okay. New variant of COVID-19, which has a different impact from the previous COVID-19. Can it be predicted using mathematical modeling? Yes, there are many interesting, our limitation is time and our knowledge. Actually, there are many approaches of explaining, or not forecasting variants of COVID-19. Even there was one using geometry, the shape of the virus, and using mathematical geometry to explain what possible new shape of the virus and things like that. It was interesting if I understood the talk that I attended correctly. So yeah, using mathematical modeling, I think it depends which model, but there are many approaches that, if I am not mistaken, may be able to explain different variants that may appear from a disease. So that's my take. And then whereby as a model for COVID-19 as well, as we know that the man who's can be infected again, yeah, or who recovered can be susceptible again. Yes, there are many papers, many works done on modified SIR models. There are too many. And each one proposed a different approach, different take, and including a question here about the possibility that a recovered person can be infected again. And yes, yeah. So the answer is yes. There are many works already on that case. So what I showed before in SIR, from S to I and then from I to R, and that's it. There is no return back to S. That was the simplest, the earliest, and in the original model. I think that was introduced by I forgot the name. Yeah, but yeah. So it was the most primitive, the original model. But modifications of that model, many of them. There are too many even to follow. Yes, thank you.
Okay. We have finally reached the conclusion of the panel discussion. Before I conclude this panel, I'd like to draw a conclusion from the speaker's presentation. Mathematical modeling or scientists can predict or forecast future condition or could be used to government policies to face the condition. Science and government policies must be work together. Science as the approach methods and government as the actor to solve the problem, maybe. Okay. Thank you very much, Prof. Hadi.
Thank you.
We come to the end of this session, but before closing the session, I want to share a certificate for you as a thank from ECM2A 2022 committee. Okay, wait a minute. Could you see my screen sharing, Prof. Hadi?
Yes, thank you. Thank you so much.
Okay, thank you so much, Prof. Hadi. Okay, we appreciate you, Prof. Hadi, for joining us today. I hope to see you again, and on behalf of the entire audience, I appreciate your extremely active involvement. Finally, please applause to the speaker and yourself. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Mr. Hadi.
Thank you. Thank you, everyone, for listening. Thank you. Excuse me. Okay, saya pamit dulu. Assalamualaikum.
Thank you, Prof. Hadi.
Waalaikumsalam. Terima kasih, Prof. Hadi.
Sama-sama.
Now we get back to Ms. Sinta as a moderator.
All right, thank you so much, Ms. Rara, for leading this discussion with Prof. Hadi. And the next session is plenary session with Dr. Goh Hang Wen from INTI International University, Malaysia, that will be led by Mr. Dafri Ahmad, SPD MS. Hi. Kepada to Mr. Dafri Ahmad, time is yours.
Oke, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone, all participants. I say thank you to the moderator, to the committee to give me a chance to be a moderator for Dr.
Go. Yeah, you can just call me Dr. Go. Yes, Go.
Yeah, Go, Dr. Go Kang Wen, or we can call Dr. Go.
Yeah.
Okay, my name is Devri Ahmad. I'm going to be the moderator of this session, the fourth session of the sixth ICM2E 2022. Okay, before we start, I would like to introduce Dr. Go to all of us firstly. Okay. Okay. Dr. Go Kang Wen, or we can call him Dr. Go, finished his PhD from University Technical Malaysia, Melaka, UTM, with dissertation hybridization of deterministic and meta-heuristic approach in global optimizations as his topic today related to this dissertations. And Dr. Go finishes master program from the University Malaysia Terengganu UMT with dissertation global optimization using non-parametric field function method, and finishes BSc program in computational mathematics from College University Science and Technology Malaysia Custom. Today, Dr. Go is a dean at the Faculty of Data Science and Information Technology, INTI International University. Okay, so I think that's all about a brief introduction about Dr. Go. Okay, stop.
Okay, thank you very much, Ahmad.
Okay. Today, Dr. Go will present about the hybridization, meta-heuristic optimization, and its applications. We will give the time to Dr. Go shortly. Please, Dr. Go.
You can see my screen?
Yes.
Okay, good. Okay. Good afternoon to everyone. Thanks for the chairperson, and also thanks for the invitation for me to become the keynote speaker. This is the first time I become the keynote speaker for the conference. Thank you very much. And I can see the panelists. We have a lot of very experienced lecturer, and also the professor become the keynote. I think I'm still very young in this. Hopefully my sharing can bring some knowledge and also contribute to all of you. Okay, thanks for the rector and also deans of the faculty and moderator. So today my topic will started with this hybridization of meta-heuristic optimization and its application. So basically, I'm coming from this Faculty of Data Science and Information Technology from INTI International University. This university maybe is new to you, all of you, because but it's already 20 years in Malaysia. We started our collaboration now, and we are welcome if we any university or partners would like to partner with us. We started with a lot of Indonesian university also. Currently, we working with Undip, University Airlangga also, and UAD. Okay, so we hope coming soon we might become a partner with University Negeri Padang after this. Okay. So as the theme of the conference today, we are talking about IR 4.0. I think this is what we talk about, the Industrial Revolution 4.0, and a lot and since this morning, Prof. Paulo also mentioned about the data science. Okay, all this. So when we talk about Industrial Revolution 4.0, people are talking about the new field of the industry is now data. Okay, I think we started with the steam power, then electricity, and then the oil, petroleum. Okay, then now we come to the industrial 4.0, which is more to the data. So people are talking about the data science. Okay, and the 5G technology. Okay, have changed our way of living, right? And especially after the introduction of the 5G, and we have experienced the pandemic, the COVID-19 pandemic for the past 2 years. The COVID-19 for the past 2 years actually have accelerated the entire of this technology. Okay, come into our life. Okay, so a lot of people nowadays start working from home. Okay, we enjoy ordering food through the food delivery service. Okay, no more shopping. We already used to online shopping. So all these have contribute more and more to the big data era. And 5G is actually, people are talking about the internet of things. It's not internet for human. Actually, for internet for human is, people are talking about the when 3G and 4G time. That's the technology people are talking about for internet for people. But now, when we have this 5G, basically we're talking about when all the devices, all the how to say, all the things in our home that it going to communicate. Okay, maybe your TV will communicate with your fridge. Okay, and your auto gate will communicate with your aircon. You know, all this, it will be linked up with the internet. So it will contribute more data. So people are talking about big data today. Okay, and so when AI is coming to the industry, okay, a lot of people are talking about AI, Internet of Things, cloud computing. Okay, to be honest, as you can see just now from my background, I'm a mathematician. After I become the dean of this faculty, so I can integrate the mathematics into all this IT, and I realize whatever that they mentioned about big data, AI, the core behind all these are still our mathematics and statistics. Okay, like this morning when we talking, Prof. Paulo have mentioned about statistical learning. Machine learning without statistical learning, I don't think it will learn. Okay, so a lot, and AI itself, right? If without machine learning, it also won't work. Okay, so what I'm trying to say, to all the audience here, I know. I think in this conference, many of us are all mathematician background. Actually, we will contribute. This is our era. Okay, when people are talking about big data era. Okay, so actually this is our time. Okay, to contribute. When we talking about mathematical modeling, like just now, Prof. Hadi have mentioned about the mathematical modeling for the COVID-19. You see, even something that related to disease, but they still need mathematician like us, okay, to help to modeling the things and do forecasting or do prediction. So a lot of these actually we will involve. Okay, so you can see and this is the keyword that people talking about the data science nowadays. Okay, we talk about the predictive analysis. Okay, data mining. All this is actually something related to computer science, but the core behind still actually from mathematics. Okay, so but my focusing today, as I can mention just now, when we're dealing with a lot of data, and then people are talking about the machine learning. Okay, so they actually, inside the machine learning part, there is a part called mathematical programming, which is the optimization. Okay, before the system help us to do any decisions. That's why when we talk about decision science, optimization is a very important part. Okay, so all these, the optimization is playing a very important part in coming era. Okay, so we need to go into this. Okay, as you all can see just now, my background of study is very focusing in the global optimization. And my master study itself, I'm focusing in the deterministic. Okay, I started my research in optimization since my bachelor, and then I focus on the deterministic of the global optimization, which is the field function method. That time I thought something must be mathematics for us is very deterministic. Okay, 1 + 1 is always equal to 2. We will never say 1 + 1 will equal to something else. So that for me that time I was very deterministic. So I'm study on something very deterministic. But until a level I learned in master, until a level, a lot of things cannot do without stochastic, and a lot of things happens uncertainty. Okay, so the statistics should come in, and then the heuristic have to come in. That's why I started to change my pathway after I finished my master. So I start focusing in the heuristic and go to the meta heuristic, and that's why at my PhD level I start to hybrid the meta heuristic approach together with the deterministic that I'm familiar with. Okay, so I started all the hybridization, how we combine, how we modify, okay, and how people are modifying the meta heuristic method, all this, okay. And as we can see, these are the list of the meta heuristic approach, okay, been introduced, okay, in the optimization. So we have methods that involve evolutionary, okay, like GA, okay, evolutionary programming, okay, all this. Or we have the physical base. They based on some physics concept like simulate annealing. Okay, they talk about the heat. Okay, and we have the swarm based kind of optimization. Okay, and so swarm based, then we split into like particle swarm, then we have the cuckoo search, we have the ant colony, we have the artificial bees colony algorithm. Then we also have the nature inspired algorithm, for example, like whale optimization algorithm, the bat algorithm, kind of things. Okay, all these are the modification come out in the meta heuristic approach. Okay, so in my PhD I start to modify the artificial bees colony with others with the deterministic algorithm. And you can see the series of books are talking about the hybridization, about the meta heuristic have been introduced, okay, in this. And because of the advancement of hybrid of meta heuristic approach, then there's another level called hyper heuristic approach, which is they no longer hybrid, they gather all the meta heuristic approach together, like just now, all this group, okay, all this group of approach, they put them into an algorithm, then they have the selection whenever they want to solve the problem based on certain criteria. So so inside the algorithm they may have different of several of this algorithm. Okay, for example, they might combine the particle swarm and then artificial bees colony, cuckoo search, and also genetic algorithm, and also the whale optimization to get algorithm in one system or in one approach. So when they started to solve the problem, they was try and error by sending out different approach, go and solve the problem, and they choose from there. That's called hyper meta heuristic. This method, this approach have been started to popular since year 2018, okay, and 2019. So people are start to moving into this kind of approach, no longer just hybrid, changing modification by combining two different meta heuristic approach or whatever. Okay. So actually, when come to this natural inspired approach, I learned this term called biomimic. is an approach we talk about when human want to seek for sustainable solution. Okay, this started introduced when the sustainable goal development have been introduced in 2015. Okay, then they talk about the biomimic so that we can seek the sustainable solution. Okay, from the nature. Okay, for example, like we try to learn from the ants, okay, how we can reduce the traffic jam. Okay, so that's what come out. And we learn from the handbag wheels, okay, how they create the efficient wind power. Okay, so a lot of design we try to go through the nature and find a solution. Okay, and we learn from the termite how they create the sustainable building. Okay, so we started in architecture. They learn how the termite building their hive and then try to mimic the solution. Okay, and in medicine they learn from the mosquito how to come out nicer needles. Okay, so that I think nowadays when you everyone have experience through the vaccine taken. Okay, so I think you won't feel any pain when you take vaccine because nowadays the needles have become very tiny. Okay, and also we learn from the dolphin how we send the signal underwater. Okay, so this one is from communication. That's why we have a lot of telecommunication technology. Actually, we learn it from dolphin. Okay, and last one, the bees. Okay, and bees is a very intelligent creature that you can see from their hive itself. They found out the hexagon is actually very powerful. Okay, that's why I think in mathematics, during high school, we learn our trigonometry through the super hexagon itself, the concept, right? So I think, and they actually found, the research found out the hexagon itself, actually, it can build into a building that we can bend. That's why you can see the bees hive, okay? They are structured like that, and they can store the most honey inside, okay? That's so my research is actually focused on the artificial bees colony. Okay, so we're talking about the so in artificial bee colony itself, they split the bees into two categories. One is from unemployed bees and then to employed bees. So for unemployed bees, they will start to do two things. One is for scout. So the scout will randomly search for a new food source. Okay, so this one is the scout bees. So these bees are the one who started the exploration. So artificial bees colony algorithm, it will consist of two phase. The first phase we call it as exploration. So once the scout bees found the food source, okay, then they will ask the onlooker bees. Okay, so then they will start. Then they will become the employed bees. Okay, to do the exploitation. Then the other group of the unemployed bees will follow these employed bees. Okay, to do the exploitation. Okay. So among all the study during my time, we found that in the literature, the artificial bees colony, they have a very good exploration, and then they have a very bad exploitation. So I'm studying on the bees colony. So basically, they will have the scout bee go and search for the new food source. So after that, usually bees will come back to their hive and do the dancing, and then the onlooker bees will follow the employed bees, go to harvest the food source. Okay, so until the food source have been fully harvested, then they will abandon and become the scout bee again and look for a new food source again. And then this is the whole cycle of the artificial bees colony. So for the original bees colony, what they do is after all the bees, okay, or after all the scout bee found their new food source, okay, so they will start moving to how. So when they started to exploit the food source, they were following the direction of the next bees. Okay, for example, in this picture, you can see they have 7 bees found their new food source. So the first bees will follow the after they found it the new food source here. When they want to do the exploitation, which is the local search, they will move according to the next bee's direction. Okay, so they use the direction of the next bees. So they will move from here, but of course the distance will be less than one unit, so that they can do the exploitation. So this is how the original bees, original ABC move, and then there's another called GBAS. Okay, the GBAS, it will depends on the two bees, the next 2 bees. Okay, for example, the first one will follow the second bees and the third bee direction. Okay, you see the distance between the bees number 2 and number 3. So the combination of these 2 vector, it will become the new search direction. So for example, the second bee will follow the third bees and fourth bees. So these 2 direct vector, it will build the new direction here. Okay, then the third bees will follow the fourth and fifth bees. Okay, so these 2 vector, it will build this new direction. So this is how the bees algorithm move. Okay, the GBAS. Okay, so they and the result they prove is better than the original bees ABC that they introduced. And then we have few more, which is, for example, like this one, the best so far. So it will, every time after they move, they will follow the best so far. For example, now you have 7, okay? Then this is the best. So everyone will move to the best direction. So after they move one time, and then they will determine which one is the best, then they move. So after that, after they move, then they will find this one is more efficient compared to the previous 2. Then they come to another one called IABC. IABC basically combine the GBAS and also the best so far. So it not only follow the it not only follow the best solution, but also it will take the second solution. So from these 2, they build the new direction. So after that, they move again. So this is from the IABC. So my research that time, actually, I found that since the IABC that involve 3 of them, okay, for example, they will involve the second one and the third one. So 3 of them group up and build the new direction. So I actually, when we learn simplex method, I think everyone learned linear programming also learn simplex method. Then and we found that simplex method actually move in triangle. Okay, so from there I try to modify the simplex method by try to modify the artificial bees colony by add in learn from that 3 point. So every 3 point I will build a triangle. So after that, then for the movement of the next triangle, it will follow the Nethermate simplex method, and it shows a better result. Okay, then after that, from there, I actually try to, from the Nethermate simplex method, I modified through gradient-based algorithm. Okay, and one of the algorithm is like this. So I change it to the steepest descent. So the exploitation part, I actually change it to steepest descent, which is the algorithm 2.1, which is the steepest descent. So after they found the new food source, then when come to the exploitation, then it will change to this, and it will harvest until the end. Okay, so the result shows that, okay, this is original bees, so it takes more longer time compared to the steepest descent that we modified. Okay, and these are the result. Okay, it shows that steepest descent have fast convergence compared to the original ABC. So, and you can see it's it improved a lot. And this one, we only applied the most simple simplest descent. After that, actually, we do apply into the conjugate gradient itself. And also recently, we have published the paper about the hybridization on the artificial bees colony with the quasi-Newtons. Okay, as you all know, in gradient based, the faster the basic one will be the gradient based, which is the steepest descent. Then we have another one, we call it as a conjugate gradient. Okay, which where they are direct, we are using the conjugate direction. Okay, conjugate gradient direction to solve the problem. So we combine that into the and this paper, we actually use conjugate gradient as the core. We mentioned the ABC is actually to improve the conjugate gradient. So the conjugate gradient have been improved to solve those non-convex optimization problem. And but these two paper we are peer review from the ABC side, which is we hybrid the deterministic approach into the ABC. So the ABC have improved the result. And current, so these are the approach that I focus on the optimization. But of course, the application now that I'm working on, as just now, if you go through my CV, I actually having one research grant talking about how we apply this artificial bees colony in a portfolio optimization. And we also focus in Islamic portfolio optimization. And I have another project that work with Malaysia government, which is AI box. Okay, the artificial intelligence box for precision farming and also smart manufacturing. So my optimization is part of the solution. Okay, that's all from my presentation. I hope it's
okay,
not
thank you, Dr. Go.
Okay.
Now we have about 30 minutes for question and answer sessions. For the participant who would like to ask any question, please, you can ask it directly by raise your hand, or you can write it on the chat box. Okay, Dr. Go, while waiting for others' questions, I would like to ask you something.
Yes.
Yeah, okay. So you are working on meta heuristic optimization, right?
Yep.
Actually, in meta heuristic, people study about the animal habits and then make some algorithm to do some optimization, right?
Yep.
Yeah.
That's why, like I mentioned just now, a lot of people, because of the biomimics. Okay, so
Yeah,
a lot of people
biomimicry.
trying to learn from the animals or from the swarm or
Yeah.
from some different kind of living things. How
Okay.
this create the sustainable solution. Yep.
Okay, you try to do some hybridization. And I would like to ask, have you tried to do the hybridization about more than one animals, maybe and bees, maybe, or others?
Yeah, from the literature review, right, as I mentioned just now, there's a series of book talking about hybridization of meta heuristic, and many of them, they are actually focused on hybrid the meta heuristic with meta heuristic. Okay, just for your information, I think determinist. Just want to clear the deterministic approach and then stochastic approach, and then we have this heuristic approach. Okay, the deterministic approach usually meaning the method have been developed according to theoretical proof that once you finish and you will have the solution with a theoretical proof. But usually deterministic approach will take a very long time to process because it will go through almost every single point or every single solution, the possible solution that it would theoretical proof that this is the global optimization solution.
Okay.
So it will take very long. Then we have another one called stochastic or the heuristic method, but that one usually people are talking about stochastic. So they have limited time or limited probability. So they based on probability concept, then they just look for good enough solution. They look for good enough. Okay, and then they then come into this meta heuristic. Meta heuristic, as I mentioned just now, they learn from some living things how they solve the natural inspired algorithm, how they solve the problem. So not all these algorithms are work well in every single problem. Sometimes, for example, like bees colony, sometimes in certain problem they work very well. But when go to other problem, it might not work at all. That's why we call it as heuristic. Heuristic means try and error. You sometimes work, sometimes not work. Okay, so a lot of people, because of not working, so they hybrid the meta heuristic and meta heuristic. So you see, if the probability that this method can work have you combine with another meta heuristic, it will like ruin the situation. I feel like it will reduce the probability. That's why my focus that time I will try, since we have this meta heuristic that sometimes work, sometimes not work, but why not I use the deterministic approach to combine, so it will improve the efficiencies. That's my idea that time. But to be honest, a lot of people already hybrid meta heuristic and together with meta heuristic. You can just Google it. For example, like bees colony, they hybrid with the wheel optimization algorithm. Cuckoo search into the ant colony. Yes, they are a lot hybridization. That's why the series of book have been introduced.
Okay, we still wait for questions from the participant. Please, you can write it on the chat box or raise your hand. Okay.
Maybe they are hungry for the break time. Because my next after me is the break, right? Then
yes, it is after break and it's sleepy time. I think. Okay. Next, I would like to ask you something again. While waiting for others respond.
Okay, sure.
Okay, I read some before about the meta heuristic, but not the basic concept, only the application like an algorithm or a genetic or others. But I cannot find the concept about when does that optimization work and when it's not work. Okay, could you like to tell us about that? Is there is no situation that should be satisfied to work with them or not?
So far, for meta heuristic, that's why a lot of publication they do a lot of application, and they will never say confirm guarantee will work this way and confirm the solution from this meta heuristic is really work in the real life. So that's why we need to try. Once you get this the simulator to find the solution for you, then you have to like verify with the real application. Okay, and of course sometimes it might work. That's why when those work, it will be published, you know. That's why so a lot of paper nowadays that they produce are all the example that work in this. But many times when you are working on this meta heuristic approach, then you will know sometimes they can't find you the solution. They, no matter how you try, they just can't find you the solution. Even you restart it and then you change the parameter, you try to adjust all the parameter, it just cannot produce for that problem. That's why we understand that heuristic itself, it meanings is like try and error.
Yeah. Okay, actually I asked this because some of our student on the undergraduate level research use this method, but they never guaranteed that it will work or not.
Yes.
Okay.
That's why a lot of research in this part, and it's still a very wide area. And just for your information, machine learning. Okay, why people like meta heuristic? Because they use a very simple concept. They never bring in a lot of optimization theory into meta heuristic. A lot of meta heuristic algorithm are developed by electronic engineer, computer scientists. They will just use the numbers, you know. That's why you see the original ABC, the direction is just based on that second. They will just minus. They was just use, okay, this point minus this point. Then they found that, okay, this one they will move. Then they will put in some parameter in front of that. It become the coefficients. So it's become, in optimization, we say that is the step size. So you have the direction, you have the step size, so it move. But in computer scientists, they will just treat that as the, you know, number minus numbers kind of things. So they do not have the pure background, the theoretical background like us in mathematics. So when we see, when you take the two point, you minus each other, is basically is the vector. We know is the direction. That's why another researcher say, come to the GBAS, they take 2 point, okay, they minus each other, then put in the parameter. So they, okay, for the first one we will have a bigger coefficient, the second one we have a smaller coefficient. So actually it's the combination of two vectors, something like that. So they never thought that. But in mathematics, yes, we learned this in vector, and we know that it's going to move like this. So a lot of theory behind, we need still need us to go and discover it. Then we that's how meta heuristic sometimes is work, sometimes not work, and we have to go in and study then to make it more how to say, increase the probability of them working in a lot of application.
Okay. Okay, we still have about 10 more minutes, Dr. Go, but no one asked the questions.
I think most of them opt for early break.
No, most of them has been understand about your explanation, I guess. so understand.
Yeah, maybe it's too technical, because I think most of you are mathematics education background.
No, actually. I think only about a third of us is mathematics.
Oh,
Mathematics.
so most
It's
of them are education background.
yes, most of them are education background, but still we still have a big part of us is mathematician
Okay.
background. Okay. Okay, others question from me. When as a moderator, I should make this discussion flow. I think. Okay, other questions. Okay. Oh, sorry. There is a question from Daniel Benito.
Okay, I think a very common algorithm that used and widely used is the genetic algorithm. Okay, because genetic algorithm, they have the crossover and the mutations. Okay, and is easier to apply. That's why a lot of people are applying in the using this GA. You can see genetic algorithm everywhere, right? So
Yes.
genetic algorithm is another one beside this bees colony algorithm. But of course, the for example, ant colony algorithm are very specific. They use to find the shortest pathway. Okay, because ant colony is basically talking about how they work, moving into the move in the shortest pathway. So it's for salesman traveling problem is very useful. But genetic algorithm, the feature selection inside the properties, it can be changed and applied according to the problem. That's why genetic algorithm have been applied a lot. Is one of another common algorithm. Okay, so that's the two popular one. Basically, one is a population based, which is the bees colony. But nowadays there's a lot of different name have been come out because those researcher may go to somewhere and they see a creature at that place, then they create something. That's why, for example, the cuckoo search have been come out, the bat algorithm have been come out. All these have been, and I remember a few years back, I heard about the strawberry algorithm. They're talking about how the strawberry trees grow, and people study on that. So they say actually strawberry trees, when you plant at somewhere, then it will actually shoot up the how to say, the root or whatever. Okay, then he will grow another tree nearby. It will spread. So from there, people study on the strawberry tree and develop algorithm. Also got. So different and different people are they will use different specific algorithm in their application after that. For example, like myself, I started with this bees colony. So in my application to portfolio optimization, in my precision farming, then I will use that as my base algorithm. But I met another researcher earlier. They talk about the hyper heuristic. Is also another area of research that you all can look into, which is they are not doing any combination, but their algorithm is like you design a set of algorithm. So you will try to different algorithm to solve the problem. Then the best one, then you choose. So inside your algorithm itself, you will have the GA, you will have your bees colony, you will have the wave optimization algorithm all inside. So it's like a package that that time I remember the professor Kamal used the Avenger teams. You know, you have your Iron Man, you have your Spider-Man. I still remember. I think that time it was the Pak Irwan with me together in the conference. That's the time I know Pak Irwan from UNP.
Okay, Dr. Go.
Actually, I visited UNP 2006. During after I graduate from my bachelor, it's a lawatan sambil belajar from KUSTEM.
Okay.
Yeah.
Interesting. So you have visited our campus before.
Yeah, I visited Padang, Bukit
Yeah.
Tinggi. That time, that in that trip we visit UNRI, UNAN, and UNP.
Okay, it will be great if you come here again next
sure.
time.
I like nasi padang. Yes. even now my place Nilai. Okay. Inti actually now located in Nilai. Is a lot of people from Padang, Minangkabau.
Okay, Minangkabau.
We still have a lot of house, the Minang
Yes.
house like in
Yes,
Padang.
rumah gadang.
Yeah. We do have it in Nilai here.
Yes. We have historical background with Nilai actually.
Yeah.
Oh,
That's why I hope one day we can connect it, UNP and INTI after this.
okay, it's okay. Okay, I think we have met with the time of this presentation. Okay. I think there is no other questions. So I think it's all, Dr. Go.
Yeah.
Okay.
Yeah. Okay. That's all. Thank you.
Okay.
Thank you, everyone.
All right. Thank you very much, Dr. Go. We come to the end of this section. But before closing the session, I want to share a certificate for you as a thanks from our commit. The ICM2A 2022. I will share the certificate. Okay, this one is for you. We will send it soon to your email, Dr. Go. Okay.
Thank you very much. Very
Okay.
nice. Thank you.
I think the commit need to take the screenshot first. Okay. Okay, thank you very much for this session, Dr. Go. I will give back to our moderator. Okay, Miss Sinta, the time's yours. It's all for me. I say sorry for all bad from me, and thank you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Dr. Go, and thank you very much, Mr. Defri, for leading the discussion. Thank you, Mr. Go.
Thank you. Okay.
And ladies and gentlemen, before continuing our main program plenary session, we are now in a break time for Asar prayer. Please be noted that we will be back to our meeting at 4 p.m. Thank you so much.